All right, we've got the first ply on. You can see the butt line here. Second ply goes from this intersection to the intersection between the outboard and the middle block. What we'll do here, we take this material and we cut right up against the end of the foam and fold it down, lapping it across the leading edge. Leave about 2 to 3 inches of material folded over the leading edge. If your first ply was 3 inches, make your second ply 2.5, a little shorter than the first. Down the full length. When we finished cutting, we've got a full lap here. There's your first ply, about 4 inches. Second ply, about 2.5 to 3 inches. The spar cap is still soft, still green, so you can, every time you run a piece of cloth around this around this edge, you can form the spar cap edge to get a nice radius. You can feel the flocks under your fingers forming this leading edge. Not really a leading edge, but spar cap edge. Cutting on down this edge. Don't destroy this piece because you can use this. Now what I've done is I've stippled the edge cloth down. If you can see the yellow selvage there, I get the selvages close to one another. Your cloth is going to be a little different than this. It isn't going to be, it's not going to have these hairs sticking out the selvage. Your ears will be a lot cleaner than this. Now I'm going to wet this out and butt the other ply that's already down on the table up against it, wet it out, and then we'll put the third and last ply on. There's a few other minor details that we'll cover as we go along. We finished with the last 2 plies. The surfaces are relatively wet. We're going to put a third ply on, and if you look at the aileron area, you'll notice a tape of Dacron, 4.5 inches at the outboard end, 6.5 inches at the inboard end. What this represents, if we were on the opposite side of the wing, was where the hinge line is of the top side of the aileron. We don't want mass aft of the hinge line. So when we run our unidirectional carbon fiber on the underside surface, it'll go right up to this edge. These are going to be removed immediately after we get the carbon down. And we'll be laying that up for you in a moment. Okay, step beyond the end, and Richard's going to control the selvage edge. I'm going to pull a little bit more from you guys. A little more over. Other way, Richard. Other way. There you go. A little more the other way. West, east. That's close enough. We'll just cut it off and relieve you guys of your efforts. Thank you, Ron. We're going to pull our cloth. Okay, Richard, grab that selvage edge and pull hard, really hard. There it goes, that goes, you got it. I'll adjust this. Okay, grab right about here. Pull. There we go. And we can adjust the ends by pulling from here. Okay, right here. Okay. All right, one more time. Let's give it a stretch. You got a wowie right there. It's not a bad one. A little one just the same. Okay, pull tight. I come through here. Looking good. Done. That's the application of the third ply. We cut and trim. And we lap it onto the forward face of the shear web. Point where, Richard? We've got 2 inches. On the last lap, we're going. The Dacron tape represents 30 inches. We're going to run another one across here. It's going to be cut. Here's the width of the spar. We're going to run the cut from here to a point 3 inches from the leading edge. We'll do the same from here to 3 inches inboard of the inboard of the outboard end. It's getting late, folks. So it will look like this approximately. I'll make that cut now. First thing we'll do is we'll cut this leading edge section off. We'll come up 3 inches. Let's see if I can cut a straight line. Kind of like navigating the dead reckoning. Pick a point in the distance and fly to it. Three inches. Pick that up, Richard, would you? Falling just short of that isn't going to be of much concern. We'll do a quick wet out of this piece. And we'll lay one up the opposite angle. We'll be back to you for the second layer. You on?
We're on.
Okay, we're going to cut this one back just a little bit from the other one. There's the first one. Quarter to half an inch or so. Tap it down. You can see there's the grain orientation of the first layer running this direction. Second layer running 90 degrees to it. Gives you a 45 degree, essentially a 45 degree bias ply of material on the surface. Obviously, too, we can forget as well, and this is what we forgot. You have one on here that is 4 inches by 11 inches, and another one in width 4 here, 11 uni, and 4 here, and 8 here, flapping right over top of your outboard bolt position.
Which way is the grain?
Grain orientation is straight fore and aft over top of this position.
Care to talk about the whole process of vacuum bagging, like the baby, all that?
Sure. This is an optional section of the plans. This is vacuum bagging. We don't normally Dacron an entire wing surface. Usually we wait for it to tack up and then we cover it with microballoons. This will be very different because of the vacuum bagging. Try and get all the wrinkles out of this thing. Get this laid down. After the Dacron, we lay on a layer of perforated Tedlar, Mylar, any number of different plastics that are perforated. Principle being that when you apply vacuum, atmospheric pressure pushes on the surface, forcing resin up from the laminate below, through the Dacron, through the perforated release film, which is what it is more commonly known as. Take note of where your bolt access port is, because what we're going to do is put what is called a call plate over it so that the vacuum does not push the laminate into that depression. We'll be call plating several key portions of this wing tonight. One of them will be, if you look down the torque tube hole here, inboard, right here, we'll be going past this intersection about an inch with an 063 call plate, 8 inches in width, the full length. This is so that the vacuum bag does not crush, the vacuum process does not crush this torque tube area. The same thing will be done on the opposite side from underneath. I didn't comment on this during the layup process, but the first 2 plies went on relatively wet, and the 3rd ply should go on very dry with the use of a hair dryer to pull the extra resin up from underneath, making it as dry and laminate as you can. We didn't employ those methods here because we're going to vacuum bag the wing and get the extra resin out. But I should encourage those who are going without the vacuum bag process to squeegee the wing judiciously, as was done on the winglet section, to remove the excess resin. We're lazy. The vacuum bagging process will remove that extra resin for us. Trailing edge close. Yeah, that's about right.
Tape is rolling, if you want to say anything.
Okay. When this goes on, we're going to get masking tape. We'll cut it about 2.5 inches down from the leading edge, and about far enough here where we can get tape here. What we don't want the bag to grab a hold of this laminate and pull it up into folds. So by tying the perf down at the front and at the back and on any given end, we eliminate that possibility. Richard, would you please get the masking tape out and tape this Mylar around the corner, full length. Stick one down here for the moment, and that way you can pull tight. Not up onto the surface. There you go. And then one on your end, while pulling tight. Tell you what, why don't you want to, here, stick it halfway on. That's not what I was going to do, but that's cool. Let me pull tight this way. Go for it. Now then, sock. Like so. Take your masking tape. Tack. Tack. I'm not rolling it around the edge because I want to be able to make it as straight as I can. Pull it right here. Snip. Sharp scissors always help. Razor blade maybe, Richard? Fairly well attached down there. You want to make sure that you are about an inch from the lower portion of this shear web, so the same method can be employed here in an area where it's less likely where resin would have slopped onto the surfaces. So we can put one here in the middle. One here on the end. One well inboard. We'll bring the video around and show you what this looks like here in a moment. So we have a nice tight smooth surface on the upper side. We're going to grab this about mid-span here between our two tape attachments and tie it down. If it doesn't want to stick down, grab some pieces and pull it around the front side. We're not getting very good attachment, so that will provide us with no choice. Now we're going to cut the leading edge off and do the same thing down the center. Don't throw this stuff away, it's expensive. It can be used in all kinds of other parts. I may have more success with attaching to my leading edge than I had last time. We'll see how it sticks. Very nicely. As you folks find simpler ways for doing some of this, you might let us know what they are. We're always looking for new and better ways of doing almost anything, and we'd be happy to hear from you in that regard. Pretty easy to see where call plates are concerned, where they must go. Call plate in this area has to be centered over top of the torque tube opening. This one as well, same position. This one's not nearly so critical since the foam is very thick in this area. It's less thick at this end, and it needs to be placed over the center of the oblong cutout. That can be seen by looking inside the tube. You can't really do it with this one. With sufficient light around the area from underneath, well, maybe we can show that. Let's see if we can take a look. Can you hold that right about there? Let me take a look. Hold on. Let me see if it sees. Okay, taking a look down the end. You can see the light at the end, and then by bringing the camera up, see if you can see that your hand is over top of it. You can see that it's directly placed over top of the opening. That's pretty close. If you want a dimension on that, where that looks is from the trailing edge, perpendicular from the surface, is approximately 4 3/4 of an inch, and the front, the aft edge, is 7 1/2 inches. We're going to tape the call plate up. We'll be lifting the wing to place the plastic in place. And Richard's going to get a view of this from his end, from underneath. When we lift the wing, these call plates won't drop off. What we have left to do now is to pick up the wing, set the 6mm plastic down, and finish the bag up. Okay, you might want to film that, Richard. Let me tell. Okay, Paul, take it back. What we're showing is that the plastic is quite a bit larger than twice the width of the wing. The wing has been carefully set on top of a layer of 6mm plastic that's been carefully set into the jig. Considerably longer than the jig, about 1 foot or so on each end. We'll take this back over to the surface. Check that everything is correct. Okay. At least now we know where to come from with our bag seal tape. Actually, right to the fold line seems to be just about right. Yours the same on your side, Paul? As one might well imagine, that this would be a much simpler task if there were several hands involved. But unfortunately, that's not always the way things run around here, or anywhere else for that matter. You want to avoid the creases if you can, but we don't have to cut this material to continue to extend down the bag. This is of no importance whatsoever. It could be just a regular standard hose. We've wrapped the hose with bag seal tape. Now we take a piece of bleeder we wrap it. Wrap that with a small section of tape. We place this somewhere inside the bag in an area where it can transfer vacuum to the surrounding area. We pitch it right in place. Now, of course, I don't need nearly what I have here, so I'm going to cut this off and splay it out onto the trailing edge area. And while handling all this, of course, it's paramount that one does not cut or puncture your bag. All this has to do is get to the edge. So we'll lap it on. When we close this bag up, it'll have plenty of access to vacuum. We're a little oversized here. Much bigger than we need to be. Now, this will be the only medium that the vacuum is traveling through. As it gets to this medium that the vacuum gets to travel through. So that's why this is here, so we don't squeeze off the source of vacuum with a plastic bag. Now we're going to fold the bag over the top. A number of ways you can start. We're going to start at this end. If you look at this corner, there's one of your first problems. Make sure that you don't have any spanners. Right to the corner. And we seal the bag like this, the entire perimeter. We'll come back to it in a few minutes. Okay, now that we've got a seal, we go around the perimeter, we look for creases and folds and hollows. At this stage, they're a mild aggravation. We hit the vacuum, and the vacuum will make this process 1,000% better. Here's an opening right there. Push it into the corner. Now we'll have to come back to that again. There's one right there. There's a leak of a bubble. And just come all the way down again. And there was one right there. If your vacuum pump is set up for pulling 28 inches or so, you want to bring that down markedly. And I'll be upstairs with a screwdriver. Ours turns clockwise to bring the pressure, to reduce the pressure, and counterclockwise to increase it. Now, while I hit the vacuum upstairs, Rich will be taking this and moving loose plastic into corners so that we don't have spanners pulling and stretching on the part. We're going to be heating this a little bit. You don't have to heat yours. You can tent it and bring it up 80 to 90 degrees, 100 degrees if you can get it. And
Floor heater.
with a floor heater underneath a tent over your table. Running a cable from one side of the room to the other and just hanging a tent on it, taping the ends closed, putting a tent underneath, putting your table and your jigs in a portion of that jig that gets it high enough to benefit from the heat in that bag. I'm going to go upstairs and turn the vacuum pump on, and we'll watch this whole thing suck down. This looks very good. On the bottom side, the jig portion of the wing, make sure it's loose and floppy in that corner and doesn't pull a span across that trailing edge. And we're going to show you what the whole thing looks like, tightened up, and how you can see the resin coming through the surfaces at the perforations. It'll be less apparent in the double wide areas, but you can already see resin coming through now in these areas. We seem to have knocked down all the leaks. We'll go do one more time. When you heat your part a little bit, you'll also improve the tackiness of the bag seal tape, and it will have even less of a tendency to leak. This is fairly representative of the process. We use 6mm plastic to avoid the probability of a puncture where the wing sits on the jig where the plastic goes over the jig. These edges have been rounded with 80 grit sandpaper so that we decrease that tendency. We seem to have no tuck down, no flexure into the problem areas we've had on another wing that we did, either on this side or on the bottom side. No distortion of foam whatsoever. Well, we've heated it to 100 degrees, which can easily be obtained with your own personal tent and floor heaters. And you can see that the increase in temperature has thinned out the resin and allowed it to move up into the absorbent layers. And we've got a double layer here. We needed it here because we have quite a bit more material here. I'm seeing a bit of flexure here, so you may find that the heating can cause flexure of your wing. So when you lay your straight edge on the surfaces, set a weight on top of the wing at this end and at the far end, and then re-examine the condition. When pulling your bag materials, exercise caution around corners like this so that when you pull the bag you don't delaminate the carbon fiber from the core. There are a number of places when applying slurry, or I should say micro, this is west, to your wing, you don't want the material. First and foremost is the outboard end of your wing, along the diagonal line, represented by the last plies of carbon that you put on the wing. And as you apply your micro, the first thing you're going to do is push it into the surface. And then you're going to let it, after you've wetted the surface, then you're going to let it smooth out, just like that. If it begins to pull on you, creating more openings than you're covering, time to stop. Sort of a feel you have to develop for when to cease messing with it. This is 13 shots. It's about 75, 80 degrees. That's pushing it a little bit. starting to pull on me. You can try changing directions. Sometimes that works, it won't work for long. The resin is accelerating and it's cure. If you find areas as you go that don't seem to be wetted, pull it off and immediately come back and push it back in place again. All what we're doing is sanding out phenolic microballoons. Looks pretty straight. Looks real straight. And if it's straight, then you should be able to sand a flat, or flats I should say, lengthwise on this whole thing. The method we use is we go 45 degrees. And we occasionally go off of our span-wise. If I'm 50% here, I'm 50% here. If I'm 25% here, I should be 25% of my cord here. If I feel I need to apply more pressure to a particular area, I go off of those lines diagonally and I'll be putting more pressure in the middle. It's important to develop a feel for this and to be able to recognize what it is that's happening on the wing. You cannot just sand willy-nilly. You've got to make your fingertips intelligent. Once you get to the point where you start getting smoothness, feel the surface. Feel a fair curve. There should be no waviness or lumps or bumps. And if you feel these things, we'll show you how to eliminate them by the use of tools that address that particular issue. One of the things you want to do when you're bar sanding your surfaces, put enough weight on it to keep it from moving. You're going to do some light scuff on the ends of your wings. You'll do a little scuff in this area of the foam. This section gets trimmed off in its entirety. This is shear web. This is low on the opposite side of the wing already, which if there's scuffing in the foam, it'll be an easy thing to repair. In the end, of little concern whatsoever. So, weight it heavily so it does not move around. Okay. This is what we see when we start making contact with carbon. And that's when we stop. This gets cut off here, 90 degrees to the forward face of the shear web. This is of not much concern. Okay, what we've done is we've sanded out the micro balloons and worked up a good sweat. And of course, when we put our micro balloons on, we judiciously avoided the first 2 inches of the leading edge. Now, I haven't bothered to trim off the glass or the carbon that protrudes beyond the center line of the airfoil. But you can actually see down in this area, I'm not sure if you can see it on tape, but what I've been doing sanding down the center line of the leading edge. Sanding less here and more and more and more down toward the center line. And as I've been doing so, as can be seen in this area, I'm going through and thinning this in the area where I most want to thin it, which is the dead center leading edge. It's supposed to be very thin here, progressively thinning back over a half an inch to the point where, thin at the center line leading edge, and getting less thin out to about this area, and then all we've done here is scuff the carbon fiber for bonding. I'll do that its entire length, and then trim down the center line if I haven't gone through all the way, either with a razor blade or a small hacksaw blade. Well, we've got the wing jigs back in place. If you'll look at the jig, you'll notice that there's a minor discrepancy of about 3/32 of an inch, maybe as much as an eighth in the spark cap area. But it's consistent at the entire length. We have the same inconsistency, the same paralleled condition on the inboard jig. And at the outboard jig, the same parallel condition. There's just enough slop in the wing in the jigs to allow movement, and this is quite acceptable. Now that the tops are back in place, we only used one bolt to hold them on. We'll take the bracketry off that's holding the jigs to the table in this area. We'll pull them off, flip the wing, and reattach. We'll be back to you to show you that section. This is one of the more fun parts of preparing your wing for your next layers of glass. And we're going to trim the trailing edge off. Almost any saw can be used. I haven't sanded the trailing edge yet where the carbon fiber wrapped around from the bottom up to the surface, and I can handle all that right at this stage. Don't be too aggressive. Don't go below this wing line. We'll come back to this after I've got all of the surfaces trimmed off with a saw, and I'll show you how to treat it with a sandpaper or a rasp. Now that we've gotten the bulk of the material off the surface, we can progress with removing the larger portion of the foam. I'm removing that aforementioned kick-up of carbon fiber left on the trailing edge. A wood rasp or any such device is going to remove foam very, very quickly. So I have to caution you to, again, be careful. And do not go below contour. Especially when you kick up chunks of things, micro and such. When you get to about this stage, get the larger chunks of foam off. And riding on the trailing edge.
What grit?
36. 36 grit paper, sandpaper is what you are using. You will resort to a finer grit shortly. I'm very lightly riding on this surface. This is relatively dull, so it's not cutting. You should have perfect transitions from this surface to here without any kick-up whatsoever, and you should be directly on plane. can make the difference between ailerons that feel right and ailerons that feel wrong. Make sure this is a smooth, straight transition. Flat along that edge. What we're going to do is we're going to get underneath the Dacron here. I'm going to fudge this since I've already pulled it up. We're going to get underneath the Dacron, get it peeled up, pull away from the wing. Just push. After we've completed that section, what we follow with is we take the sanding and put a light bevel till the foam at this edge is completely sanded. And then we lightly bevel this edge just a touch so your carbon can make a nice smooth transition to the bottom of this. And that completes the preparation. A little 80 grit, as long as it's maybe you'll see a little bit of cleft in here. Shouldn't be sanding along zealously without looking a great deal of the time. Keep the dust level on the wing down, or it will act as an abrasive. That's how it should look. A little dusty, but the next section will be on jigging the trailing edge with an aluminum extrusion. We're going to prepare the inboard end of the wing to accept 3/16 inch Nylaflow tube that gets routed into the top of the skin. And take a look down here at the top side of the wing. You'll see a red line running from this point of the wing all the way to the outboard end. The dimensions are called out in the plans at reference to them. I will mention that that outboard dimension is 1.2 inches from the trailing edge before cutting for the winglet. And what I'm going to do is place, using the eyeball method, place the 3/16 inch drill up underneath the 0.6 of an inch shell along this line. I get up against the back side of the foam and I angle up. You put your finger underneath this, about the thickness of your thumb at this stage. Now I begin drilling, still paralleling the line. You can see I come out right here. Being precisely on the line isn't important, but one of the things that we want by doing this is a very slow rate of change from here to this inboard intersection. If you come on down, Sergio, you can see the hole begins right at the intersection corner. And we're going to pass the Nylaflow through there after we route the top side. And we'll come back to you as we show you that process. For those of you who don't have a router base for your Dremel, I don't know if you can see this, we have a two-fluted, a little under 3/16 of an inch across. Maybe that is 3/16 of an inch across. It's a two-fluted router type bit. Take a piece of 1.8 thick PVC. Could be wood, could be balsa, could be even light blue foam, but this is a little more substantial. So what I do is I take the tip off of my Dremel. Your Dremel may not be precisely like this, but it really wouldn't matter. And I route her in from the end. Until I'm approximately the right depth through the block. You have the block installed. The tip of your router, a quarter of an inch beyond the base of the block. I'm going to start at the middle here and come to where the drill bit exited the foam core. What you have to be careful when doing this is that if you go through something hard, your drill bit, your router bit will heat up. And then it'll pick up a large glob of melted polystyrene foam. And then you'll leave something that looks like this, a large trough. Not really a problem. The Nyloflow will clip in very nice, tightly in this section. And in here what will happen is that it'll lay in here sloppily, and I'll have to contain it, retain it with toothpicks that are just below the surface. And I'm going to clean this bit off, and I'll be back to you in a moment. Now that we've gone to that end, I go back to this corner. I'll drop the tip of the bit into where I've started on the other side, start it, and then go this direction. Obviously, it's not terribly imperative that you stay directly on the line. It's only a guide. But if you go through something hard, make sure that you haven't heated up your bit and that you're not pulling along a large glob of melted styrene. We're going to finish this off. This isn't going to be challenging or something you need to see the rest of, so we'll get back to you when we push the Nyloflow into the core.